Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about using box and whisker plots to understand data. Let's get started. Let's start off with a quick review. Okay, so box and whisker plots display the distribution of data items along a number line. We talked about that in our last video. You can also see the smallest data point, the extreme minimum, and the extreme maximum. Box and whisker plots are created by determining 5 points. If you haven't written this down already, you might want to do it now. What we do, number one, we're going to place the data from the smallest to the largest. 2, these are our steps. 2, create a number line that shows the range of the data in equal intervals. 3, use the median as the middle point to split the data in half. And 4, calculate the median of each half or the quartile. These separate the data into quarters. And then 5, use the highest datum and the lowest datum as the endpoints, or the extremes. And boxes are drawn between the quartiles, and the whiskers are drawn to the extremes. Pretty simple. Okay, so a box and whisker plot that's already constructed can quickly supply statistical measures by looking at the 5 points. And let's go over those 5 points one more time. Number one, the extremes. The extremes are the first and the last points. The median is the third or the middle point. Quartiles are the second and the fourth points between the median and the extremes, and it gives the quartiles, and the extremes give the quartiles. The interquartile range is the range between the first quartile and the third quartile. This shows you where the middle half of the data is. And we can calculate the interquartile range by subtracting the first quartile from the third quartile. And remember, outliers are data items that are far away from the general trend. And they can be located as extremes that cause the whiskers to be exceptionally long. Data doesn't always have outliers, so keep that in mind as well. Here is an example. Let's read it. Use the given box and whisker plot to identify 1, the extremes, 2, the median, 3, the quartiles, 4, the interquartile range, and 5, the outliers, if there's any. All right, here we go. A, the extremes in this data set are approximately 35 and 129. You should be able to see that pretty clearly on the picture there, in the graphic. B, the median is approximately 95. C, the first quartile is approximately 82, and the third quartile is approximately 104, and that's where we create our box. The interquartile range then, all we have to do is subtract 104 minus 82, gives us 22. And finally, the extreme minimum is 35. And it does appear to be an outlier. Look how far that whisker goes to the left. It's very long compared to the rest of the plot. So we will call that an outlier. Now remember, outliers are points that are unusually large or small compared to the rest of the data. And when we discuss measures of central tendency, like mean, median, and mode, we must also remember that in the real world, there's a lot of exceptions. So sometimes when we consider data, we might choose to remove the outliers just in order that we can draw better conclusions based on the data. Let's look at a real-life example of how removing an outlier can affect the interpretation of data. That's one of the things I like about statistics, is they're all really rooted in real life. Let's read. Shanda runs on her school's track team. They recently ran a 100-meter dash at a track meet and recorded official times. These are the results in seconds, and you can read those. Shanda's time was 11.1, and she wants to know how she compares to the rest of her team. And she's going to use a box and whisker plot to figure this out. I guess that's Shanda. All right, here are the steps. 1, she places the data in order. And there they are, from 10.1 all the way up to 19.6. 2, she draws a number that includes the extremes. And 3, she finds the median, 11.6, and places a point on the number line. Step 4, she finds the first and third quartiles, and you can see them there. Look how little that box is, 11.2 and 11.85. Step 5, she draws boxes between the quartiles and the median. Step 6, she places the extremes, 10.1 and 19.6 on the numbers with points. You might have already identified where we're going with this problem. In step 7, she draws whiskers from the quartiles to the extremes. I will just say, look at the extreme on the high end of the number line. Might give you a hint. All right, let's take a look at what we can conclude so far. When Shanda analyzes the box and whisker plot, she finds that her time, 11.1 seconds, is barely less than the first quartile. Now she knows that her friend Teresa is super fast. She's already been offered track scholarships from major universities. Shanda doesn't think she can realistically catch up to Teresa, but another teammate, Lisa, has fallen during the race, but got up and continued to the finish line. Shanda believes that neither Teresa nor Lisa's scores are really useful in gauging her speed. So she decides to look at the same data, but remove the two outliers. This is what we were talking about a little bit earlier. So here's her new data. She goes from 10.8, now she only goes up to 12.3. She recalculates her statistical measures, and she's going to create a new box and whisker plot. Do you see how much more realistic that looks and actually more helpful for what she's trying to accomplish? So the extremes now are 10.8 and 12.3. The median is 11.6. The first and third quartiles are 11.3 and 11.7. So when the two outliers are removed, Shanda can see that most of the data is grouped closely together. Her time, 11.1, is still in the first quartile, however, her competition's tight because the rest of the team isn't far behind. So let's review our steps one more time. Step 1, to determine the median of this set of data, arrange the data in order from least to greatest. Identify the data value in the middle of the data set. For this set of data, 102 would be the median. You can pause your video if you need to and take a look at that a little bit more closely. Step 2, identify the median for the lower quartile. Again, since two data values share the middle position, you're going to need to find their mean or their average. The median for the lower quartile is going to be 93. So we take 91 plus 95 and divide by 2. So 186 divided by 2 is 93. Step 3, identify the median of the upper quartile. Remember to find the mean of the two data values that share the middle position. The median of the upper quartile is 114. Again, we're going to add 110 to 118, and then that gives us 228, and divide by 2, and we get 114. And step 4, draw a number line. The first value on the number line should be near the smallest number in the data set. In this case, the smallest number is 89. Therefore, the number line will start at 80. The last value on the number line should be near the largest number in the set of data. The largest number in the data set is 152. Therefore, the number line will end at 160. In this case, we're going to label the number line by tens. Let's just take a look at the little notes there in blue, maybe to help I explain this a little bit further. The smallest value, 89, is marked with the line, kind of looks like an I, at the end of the whisker in the lower quartile. The largest value, 151, is also marked with the same line at the end of the whisker in the upper quartile. And then the median of the first, second, and third quartiles are marked with the kind of like the plus signs. Okay, I think that just about does it for this lesson. Thanks so much for joining us. We'll see you next time. Bye-bye.